Hello, the Darkness 344 here. Today, may I present to you the cube. Oh yes, beautiful, is it not? But first, I must show you one of Bedrock's lovely bugs. So, see this piece of bedrock? Now you don't. Welcome to Bug Rock. So, here is my cube, and buttons are lighting up, which is not good. So, this is why I haven't been uploading in, what, like 2 weeks or something? I don't know, that's my normal upload schedule, to be honest. But I have been busy making this cube. And you may be wondering, what is this cube exactly? Well, this is a computer cube. So, a while ago, I think it's like 4 years ago now, Noobosaurus, who's an amazing computer YouTuber who, for like, Redstone engineering, he still actually uploads, so, you know, one of the few who still upload, and he more covers over like the logic side of things, so like, and if you're doing computer science for like A-levels or GCSEs, I would definitely go check him out, because he does some great videos showing off certain features and how certain things work. He's a lot more smarter than I am. So a few years ago he made a computer in Java Edition which was 40 by 40 by 40 blocks. It was a challenge set to him by one of his subscribers, I think. I can't really remember now. And it's pretty cool, and I thought, I had a look at the world download. I was like, well, why is there a bit of space at the back? So I was like, I bet you Bedrock Edition, you can do certain things that are a bit smaller in Bedrock. I bet you I could make a smaller one. And yeah, so I have. I wanted to make a similar computer to his. I didn't want it to be just smaller and absolutely terrible. I wanted it to still be powerful. So this is actually basically my 4-bit computer crammed into this absolutely tiny space, which is 30 by 30 by 30. So I got 10 blocks off in each and every side. It is lacking a few features which would have been nice, and which his one has over mine. However, just limitations of the space, which you'll see in a minute when I go inside. I actually got a version where I took off the coating, the cover, you could say. The case, that's a better word. I actually have a version where I took off the case, and you can see how crammed and dense it is. But I did add a few really cool features which I still like, which still makes this quite unique in the fact that even though it's a small computer, it can still do certain things which a normal computer might not have. So like, I guess the most unique thing about this is that it actually has, well, half an I/O port. So I have a serial protocol, which basically, it's an 8-bit protocol, but you can also use 4-bit data with it. I have not got night vision. Hang on a minute. Let me just give myself night vision. There we go. And as you can see, it's pretty dense, but sadly, as you can see, there is no in for the I/O. Like, there would have been an in here, like this. However, I couldn't fit it. I'm pretty ashamed that I couldn't fit it. I really wanted an I/O. I mean, you won't realize how small 30 by 30 by 30 is until you actually start building a computer in this amount of space. I mean, I thought I was going to be able to fit one of these displays in. I thought I'd be able to fit this massive chonker of a display inside that, as well as the computer. Nope. And this is actually a very, very, very small display as well. For 0 to 15, it's using a very small decoder technique that I've come up with. It's just a very easy way of decoding to a display, which optimizes space over everything else. And you can make it faster. At the moment it's like kind of slow, but that's because of my decoder. If I made this decoder a bit longer, like up to here instead, it would be a lot faster. I couldn't be bothered to do that. But however, this does have an output, so you have the O of I/O. So in, out, you have the O, you have the out. So as you can see, I did try and fit it in. I actually fit in the amazing 1 tick per bit by my Zuma Games decoder. I'm so happy that this works in Bedrock Edition. But it just did not fit, so I hooked up the output back to the input. So each time you send something from your computer, it also sends it inside like this thing, this decoder. So you have a bit of memory, like almost like a cache, basically, like storing what you last sent. As you can see, I tried to put some of the logic in, like this is a gate, I mean this is a decoder for like to save to RAM or something, but there was just not enough space. Like it looks like there's a bit of space here, but remember each one of these lines I would have to fit onto a certain thing, and each of these lines do a certain bit, and as you can see, like this, where would it go? You know, there just wasn't enough space for it all, which is quite a shame, but I mean, you know, that's what happens when it's a challenge, you know, that's why it's such a small computer. It is a challenge making something this small. So let's actually just step outside. And what I have on here, I'll actually go over the specs, but I've actually programmed it with the Fibonacci sequence, so pretty cool. And it's not super fast, but then it's not extremely slow either. So what I'm just updating the display, so it's 0. Should update now. You can specify what device you're sending to, but it's ROM, it's not actual. You can't program what device you're setting. So in your program you can't say, oh, one line I want to send to device 5 and the other line I want to send to device 7. You can't do that, sadly, because I just didn't have enough space to fit it all in. But you have it as a ROM feature here, so you can address up to 16 different devices from 0 to 16, of course. It's of course in binary, and then you also have your device commands, so you can have 0 to 16 different commands for your device, and these can be like update display, clear the display, save to cache, or whatever your display does or your device does. You can, it's not just a display you can hook up. I was originally planning, if I had the I was originally planning to copy another computer over and hook them up together to do like a program or something like that. That would have been cool, but no space for it. You can hook up like hard drives and stuff to store programs. So over here we have just a very simple display, as I was going over. This decoder over here basically decodes for 0001, and each time it decodes for that, it will update display. Anything else it won't. And this decoder over here is it's basically a comparator. If this and this are the same, then it will turn on the display, but if they're not, it won't turn on. And this is basically your device ID. You can set the device ID, and as long as your serial input is the same as your ID, then the device will do whatever it is with the data you have. So I also included a small decoder over here just so you can see, but there is one inside, of course. So without further ado, let's start it. Actually, first of all, this lever design over here you can see was actually by Nubosaurus, except these nice redstone lamps to indicate which line of the program it's on. Oh yeah, very innovative on my part. But cave noise.exe, but I actually modified it a bit, so it's a very cool decoder design, as well as the encoder. I mean the multiplexer. I always get multiplex and demultiplexer muddled around. Forgive me if I'm wrong, but I modified it a bit because he used a torch tower, but I used glass, because with glass, this is one of the cool features that Bedrock has over Java Edition. One of the few features, like, I mean, come on, Bedrock Edition. I mean, you really have bugs like breaking Bedrock with a sign, like, oh well. But here's one of the features that you can do. You can make a glass pillar, so you can do this with glowstone and slabs. Oops, that's not meant to happen. However, in Bedrock Edition you have the unique feature that with glass you can actually send redstone down both ways. So if I put a redstone torch here, you can have the signal up here, right? It goes up the torch tower, the glass tower, and if you put a redstone signal here, it will actually go down as well. Where if you had, say, a slab, it will not do this. Slabs are really annoying to build with, so this is going to be hard. Here I'm just going to go like this. This is much easier. So as you can see, it goes up. However, it does not go down. It does not go down, which is a nice feature, as you have two different mechanics which can be used in computational redstone, because this is a two-way bus technically until you need repeaters. But yeah, that's what I've been using in this computer, and it's a lot faster than a torch tower, because a torch tower, as you can see, this is the fastest design possible. Each torch is a tick, so that's 1, 2, 3 blocks is 1 tick. So every 3 blocks there's a tick of delay added, which is kind of a bit annoying. But with this, I only have 1 set, so 1, 2 ticks added. Actually no, 1 tick added, because this repeater is from this torch, so it doesn't interfere with the signal. So that's only 1 tick added in the entire, from going all the way up here, down all the way to down there, which with Nubosaurus's computer would be like a second or 2 seconds added, which is a long time compared to this. There are a few features which make this computer slow, like over here. Since this is the output of the RAM, by the way, using my amazing tiny RAM design, and the output comes along here. However, it needs to go back into the data bus. However, you need to run this wire into these wires, and as you can see, it just wouldn't fit past these wires. So I had to do a bit of slowing it down with these repeaters, which only decreases it by 4 ticks, but that's still a bit annoying. However, it doesn't matter too much, as you know, it's still quite a moderately fast computer. So I better actually show this off now, because you're probably bored with all this talking now. I will explain it afterwards, but first I'm going to show it off. So, Fibonacci sequence, and let's actually show you how to use this. So you have a few controls down here, as well as on the side, but that's because I couldn't really fit them all in one nice place, because it's so compact. You have your lights down here, your indicator lights for whatever's in the main data bus. So this side is 8 and this side is 1, and then you have clock on off, serial send, clock once, and your on off switch. So first of all, we're just going to turn it on, and it should be on line 1. And now if we turn the clock on, as you can see, it starts going through the program with a lovely indicator. And as you can see, it should start sending data through the serial to the display, which is pretty cool. And this actually figures it out, so it's not that it just sends numbers to display, it actually works it out like computers should. And as you can see, 0, 1, 1, 2, then it should be 3. It basically adds the last 2 numbers to itself to create the new number. And then 3 plus 2, which was the last number, is 5, so it should go up to 5 next. And 5 plus 3 is 8, so it should go up to 8 next. It's not super fast, as I haven't clocked it to its max potential, so I've left that to you guys. It is, so you can overclock it if you want, and then 13 because 8 plus 5. And then it should go to 21, but since it's only a 4-bit computer, it won't, because it overflows, as you can see, by the ALU overflowing. Let's just turn it off now. You can program this yourself, so you can program it with whatever, basically. I don't know what you'd want to program with. I was messing around. I have a creative world with my friends, and we were going to use it to turn lights on and off. Nothing spectacular. We could just use a redstone clock, but no, we're going to use this computer because we can. But as you can see, here's the clock. It's not clocked at its max, so you can make it a bit faster if you want, but I'll leave that to you. Of course, you can slow it down and stuff. The clock is a bit of a mess with it being kind of sideways like this, but I will. You also have this little button here, so you can clock it manually. That's just if you don't want to always have to go out the computer. Over here, I used the legendary slimestone mechanics. But basically, since I didn't have enough space to remove these 2 blocks to reset the A and B register, I had to use slime to move them both, because when you break this, as you can see, it moves them both. And that's just there to stop the redstone from dying. Yeah, I don't really like using slime that much in my redstone computers, but oh well. Also, you know what, I'm actually going to go into the test world to show you the rest of this, because it's kind of probably claustrophobic for a few of you. So let's just go into the test world, and as you can see, there may be a bit of an Easter egg for the next project. I wonder what this is. It'll be cool anyway. So here we have the word download. Oh yeah, by the way, that will be probably like part of the 4-bit computer tutorial series, so and it might even be 3 parts or 2 parts, who knows, because it'll be a long project. Alright, here we go, and nothing's loading in. Great. Okay, here we go. Oh, I have some structure blocks because I was kind of exporting these out a bit. But I will leave the world download in the description as usual, probably, hopefully, if I can remember. And you'll be spawned on this lovely platform with the 30 cubes challenge of the cube. Oh yes, so here I have it, and basically have, this is what it is. I also made a version over here that basically, let me just close the secret door off. You can break this lever, by the way, for total secret door. I have made a version over here without the stuff, well, yeah, wall, and it is pretty compact. I'm not sure I'd have been able to get this much smaller or been able to add too many more features into it, and I'm very proud of this. This took me quite a long time to make, and a lot of finagling, like just mashing things together, hoping it would fit. This ALU is stupidly small. I'll show off. Actually, I forgot to show this off. I'll show off the ALU. I had to design an ALU like that would be extra small but still kind of moderately fast to go in this. But basically, let's actually just go through the parts. So first of all, I'm going to tell you the specs. So it is a 4-bit computer with 15 lines of code. Yes, I would have liked to have done 16, but there wasn't enough space. And I used the 15th line, I mean the 16th line to, well, technically the 15th line because there's a line 0, to turn it off, and this worked pretty nicely. Let's just go up here, and then so yeah, first of all you have 15 lines of code that is fully programmable by clicking the levers. You have a nice display down here. You also have a display down here showing what line of the program it's on. You have your commands. I should have labeled them better, but you have read and write for your RAM, and you have your RAM addresses over here. So that's all RAM. And then over here you have 1, 2, 4, 8. This is your program, basically. I mean your I've forgotten what it's called now. You know what I mean, the jump to, it basically, your program counter, that's what I'm going to call it. It's basically, it goes to whatever is addressed onto this. So you can go from line 0 all the way to line 7 if you really wanted to. Don't know why you do that, but you can do that. And then you can go from line 7 down to line 3 if you wanted to. Then you have 1, 2, 4. And this is your actual ALU control, so I'm actually going to have to show it off here because you have the signs on the side. And this basically, please have the signs, there we go. And this basically just decodes out into this, and where you have your ALU operations. So this is a fully functioning ALU, so you have add, not, XOR, and, or A minus B and B minus A. These may be the wrong way around, who knows? You'll have to check that out for yourself, and if they are the wrong way around, you know what to do. Then you have ALU command, and that's the next 2. So you have these 3 over here, and then you have these 2, and this is your ALU command. So that's whether to save to ALUB, save to, well, write to ALUB, write to ALUA, or read from the ALU. And so that's what these do. There's a truth table on the side. Then you have your send, and this basically sends whatever's on the data bus So this is the main data bus, so 1, 2, 4, 8. Whatever's on this, out into the serial. And of course, round the side, you have your device ID. So this is the ID of your device, and you can program it in. And over here, you have your device command, which is the command it's going to do. I may make a video in the future covering my serial protocol in the future. That doesn't make sense. I may make a video in the future which will cover my serial data protocol, just because I think it's pretty cool and it works very well with computers. Then of course you have your RAM and your RAM commands. Then you have like a bunch of different indicators all over the place, like your clock indicator if it's clocking. You have your clock on off, your serial send, which basically sends whatever's on the data bus to the serial line. You can press this whenever it's in the program if you want. I just included that because it's quite useful to reset the display. Then you have your on off switch, and you have your clock once button, which basically clocks the computer once. So that's great for decoding, debugging even. Then you have update registers A and B, which will update it, both of them, to whatever's on the main data bus, which is useful for resetting it. So if you turn your computer off and there's nothing on it, and you want to reset the A and B registers, you don't need to do it, but it is sometimes useful in certain programs. You can just click that. You have your ALU overflow, which I'm not sure works properly, but I think it does, who knows. And then you have your reset RAM, which resets all the RAM in the system. And you have 4 cells of RAM, by the way, so pretty cool. And this is, I managed to cram 4 cells in somehow, who knows. Of course, I'm pretty sure Nubosaurus was able to cram a whole lot more than 4 cells in, just for the reason, I think he crammed 7 or 8 in, I can't remember, just because Bedrock RAM is absolutely rubbish compared to Java Edition RAM, because of you can bud power pistons and quasi connectivity and all of that, and it makes RAM a lot smaller in Bedrock Edition, and you can't do that in, I mean, I meant Java Edition, you can't do that in Bedrock Edition properly. That is pretty small RAM and pretty compact RAM as well. So let's show off some other features. I'm going to show off how it works. I don't want this video getting too long, sorry about that. But basically, so you have your main data bus, which runs from, I'm pretty sure it runs from the top all the way down to the bottom. Some of the other lines run from the bottom all the way up to the top. It really depends which runs which. Like these ones run from the bottom to the top because we didn't need the input isn't from the bottom, it's on the top. So sometimes they're a bit odd, but yeah. You have your main data bus, and your first input over here goes into the ALU registers, which will lead into the ALU, which is this over here. I'll show that off later. It's very compact. You can't even identify certain parts of the computer because it's so compact, which is pretty cool. Then this is very messy over here, but this is actually the ALU output. It was very, very, very hard and annoying to cram this in, but I managed to do it in the end, and it does work, so that's all good. Then over here you have your, I think this is your I/O input as well, or your just out input, as well as your going up this line. I think it's your RAM input. Yeah, look. This is your RAM output going back into this, and your RAM input is, I think it's actually this one as well, so it comes out from here and goes up all the way into here, because all of this stuff goes down from this way because it can't go back up. It's confusing. I mean, if you look at this long enough you'll get it, but yeah, it's very confusing. And I don't really want to explain it too much because I don't want the video getting too long. I might make a full video, who knows, like describing how a computer works and how the different parts function with each other, but that will be in the future, and I'll have to do a lot of planning because I don't do computer science, so I want to get as many terms as possible correct, and I don't want to seem like a fool and call something which it actually isn't. And so I will have to do a bit of research into seeing what's what and being able to describe stuff fully, because I know how to make computers, but I'm not that good at explaining how to make computers, and that's what I want to be able to do, because that's quite useful. So then you have your RAM over here, which actually is like this. It goes from here, but since there's not really much space, it also goes down this way as well, which I thought was quite funny. Have your RAM controls, which basically just control it. Your I/O, which is here. I don't know what this line. Oh no, this is part of the I/O. And this over here is the ALU decoder, which was a pain to fit in. As you can see, first of all, you have to decode the binary back into numbers, so you can actually get what your ALU is doing. So if it's adding, not XOR, and or A minus B, B minus A, you actually have to see what that's doing. So I have a piston decoder here. Aha, one of the features that Java doesn't have, because Pythons have the bud priming and it breaks. But yeah, it decodes, and then you actually have your decoders over here, and it's basically on 3 separate levels. So you have this level, it's actually quite hard. You have this level down here. Let's go this side is easier to see. And you have this level, because I couldn't all fit them on one level. So there's 7 commands in total, and I had to fit 2 down here, 3 over here, 2 over here, and that's 7 in total. Because of course you actually, it's all good having an ALU, but you actually have to be able to program it, and you have to like put torches corresponding to the certain bits you want to activate in the ALU. So I'm going to go show off that ALU real quick right now, because that's very useful to see. And I should really do an ALU tutorial in the future, because those are basically, you could say, the brains of your computer. It'll be working out the information stuff and a lot of pistons. I think the ALU's here. So this was the first design that I came up with, but there was a few bugs and certain things. It was quite a small ALU, but there's just a few broken features that I wanted to fix. And this is the profile that I had for the RAM. This is like 2 cells of it, so it's quite small, to be honest. And I do have a tutorial for that, so yeah, that would be cool to check out. So here's the ALU in total, and as you can see, it is pretty compact for an ALU like that. You have invert A and invert B. You have skip adders over here. You have cut carry. You have I think this was skip adders as well. So you have to activate this and activate this to skip the adders, I'm pretty sure. And then you have basically your invert output. So as you can see, I'll just try this out. And this goes from right to left, I'm pretty sure. Let's hope I got my maths correct. So if we add 1 and 1, it should equal 2, but if we invert it, it should equal 1, 1, 0, 1, as you can see. And you can also invert like inputs to be, so one of them could be 0, and it just kind of breaks. But yeah, it's pretty cool. Yeah, that works properly. So yeah, I'll have a world download in the description, also probably one on mcpedl, of course. Actually, yeah, that's one thing I've been wanting to show off. I only publish world downloads to mcpedl, so, and Mediafire, of course. That's where it actually originates from, the file, and sometimes Google Drive. So if you find some random website with my stuff on, yeah, I haven't posted that, so, but I mean, never mind. At least as long as they include links to my YouTube channel, then I'm all fine with them showing my content, because, you know, the more people who view my stuff, the merrier, of course. So actually, I'll show off a few of these weird web pages I found. So I found this Chinese one, which has my, I think this was, I can't remember what this was. I think it was my, yeah, my BCD display. So this was, I think this is pretty cool, and there's some people, as you can see. And then there's this Russian one. There's a lot of Russian pages on my stuff, which is a bit odd, as I'm not Russian, and oh well, you know, I mean, sure, they give credit, so somewhere, because I think this is, let's just copy and paste this into Google Translate. Hang on. As you know, the possibilities of Minecraft Pocket Edition are endless, and the Redstone calculator map is one of the proofs of this phenomenon. Here, the developer has constructed a calculator from a huge number of command blocks. That's not true. I made it with just pure redstone. I don't know why, but pretty much every redstone calculator or something, the people who run this site says it uses command blocks, which, I mean, can you see the command blocks? I can't see any command blocks. There are no command blocks in that. Oh, that's heresy right there. I can't believe I would ever use command blocks. Beside the creator itself, users will be able to understand circuits. Yeah, actually, since this was I keep going wrong. Since this was actually my first map that I ever released on my YouTube channel, you could say, I actually color coded all the different parts of the calculator, and I included this list over here, so saying which bits are what. So it's a nice way to start off into redstone computing if you ever wanted to start off into this, as it's a very fun topic. This is a bedrock map as well, and yeah, it's a pretty cool calculator. Just as you can see, it's a nice square build, so you have your display above your inputs, as you can see. This was only like 1 to 10, and you could just only do addition. I think I could have made it done subtraction, but you just have a bunch of like circuits, like just decoders, your adders over here, and your display over here, and you had a few more other stuff. This is a very simple build, but it's pretty nice that other people are seeing this and stuff. So yeah. Well, yeah, as always, hope you liked watching this amazing cube computer, and it's pretty cool that it can do the Fibonacci sequence, and it's still fast. I thought this would be a lot slower than it actually is, and I'm very happy that it turned out this fast, and of course you can make it faster. But yeah, I hope you have fun playing with this if you want to, and yeah, see if you can write some programs for it. And actually, here's a challenge for you guys. Try and make your own, because 30 by 30 by 30 is a very small space and it's extremely hard to make a computer. So yeah, thanks for watching. Please like and subscribe, and I am out. And sneak peek for the next thing I'll probably be doing. It involves shift registers and worm memory. You know what, I'm just going to address this now. I call this worm memory. It's actually prom memory. However, they're both the same thing. The difference between worm memory, so let's just write this out. I'm going on a tangent, I should have ended the video. Is it's write once, read many. And for prom, it's programmable read only memory, which doesn't really make sense as it's read only, but people use this term, and this is the correct term for this, as you would be using this in a computer. However, so prom is normally used in computers and stuff, where worm is used on like, so a CD, because a DVD-R, I'm pretty sure I'm getting that right, you can read it many times, but you can only write to it once. So like, say if you buy a movie, that will be, you can't rewrite onto the disc, you can only read from the disc. Whereas this is pretty much the same, but just for a computer. Prom is just for a computer, so it's where you, I can't actually think of an example, but yeah, where you like flash something and you can never rewrite to it because it's already broken. But yeah, that's just some of that. So yeah, sorry about that tangent. Please like and subscribe, and I'm out.